Welcome to the deep dive. Today we're going to cut through some of the immediate AI hype. We want to tackle a question that's actually been really foundational since early 2023 when large language models just exploded onto the scene.
Right.
And that question is this massive market for AI inference. You know, the bit where you actually use these pre-trained models, is it going to end up with just one single winner, or are we looking at something much more diverse?
Yeah, a whole ecosystem.
Exactly. So our mission today is to really unpack the surprising story of OpenRouter. It's this platform that actually grew out of that exact question, and we'll dig into the unexpected twists and turns this whole AI model landscape has taken.
And it's such a critical question, for developers, for businesses.
Yeah.
Inference, I mean, we're talking potentially the largest market in software history. It's huge.
Wow.
And back then, early days, OpenAI had such a clear lead after ChatGPT, right? So the assumption for many was definitely winner take all. It seemed almost, inevitable.
Okay, so OpenAI's out front, looking like they might just dominate everything. What were the first signs, maybe the first little ripples, that users were actually looking for something different, something else?
Well, by January 2023, yeah, the evidence started popping up. And interestingly, it wasn't just about technical stuff. It was really around moderation policy.
Moderation. Okay.
Yeah, users were really keen to understand what models would generate, what they wouldn't, kind of pushing the boundaries of what was allowed.
And this wasn't just theoretical policy debates, right? People were actually running into problems.
Oh, absolutely.
Yeah.
Real world stuff.
Yeah.
Imagine someone writing a novel, maybe a detective story, and, chapter 4, the detective finds a murder scene.
Okay.
OpenAI at that time might just flat out refuse to generate that scene.
Yeah.
Or the policies are just kind of vague, maybe against the terms of service, maybe not. It wasn't clear. And then, of course, role-playing. Huge interest there, complex scenarios. It created this big gray area around what the models were willing to do. And that lack of clarity, that ambiguity, it really pushed users to start looking for alternatives. Models with maybe clearer rules or just different boundaries for creativity.
Right, so they wanted more creative freedom, essentially. Okay, so January sets that stage, users pushing back on moderation. But then February comes along, and it feels like the ground really started shifting. There was something new bubbling up, wasn't there, in open source?
Exactly. Things started moving fast. In the open source world, those very early days, you saw models like Balloon 176B or OPT from Facebook.
Balloon and OPT, were they actually useful?
Honestly, not really. Not for complex stuff. They were more like proof of concept curiosities.
Yeah.
Almost like saying, hey, alternatives can exist.
So more of a statement than a practical tool at that.
Precisely. But, an important statement. The real turning point, though, the big one, was Meta launching Llama 1. That was also February 2023.
Oh, Llama 1. Okay, I remember the buzz around that. What made it such a game changer compared to Balloon or OPT?
Well, the Llama 1 abstract, the paper describing it, famously said it outperformed GPT-3 on most benchmarks.
Outperforms GPT-3. Wow.
Yeah. And the really astonishing part, even a smaller version, the 13 billion parameter one, that's like 13 billion data points it could run on a laptop.
On a laptop?
On a laptop.
Yeah.
And still beat GPT-3 on some of these tests.
Yeah.
Before that, you needed serious, expensive hardware just to even think about running these things.
Okay, so Llama 1 runs on a laptop, beats GPT-3. I remember reading the source quote, everyone lost their minds. And yeah, I felt that too. It was like David versus Goliath in the AI arena.
Totally.
But even with all that excitement, Llama 1 wasn't perfect, right? It still had its limits.
That's absolutely right. It was mainly a text completion model, predict the next word,
Yeah.
and actually running it locally. Still pretty difficult. The tools, the infrastructure just wasn't really there yet for easy use. But connecting this to the bigger picture, the real, birth of the long tail of language models, this idea of tons of different models, not just one that actually happened the next month.
March.
2023.
March. Okay, so what was the breakthrough moment? What unlocked this long tail?
It was the first really successful distillation, Alpaca.
Alpaca.
Wow.
Yeah, a group at Stanford. What they did was they took Llama 1, then they used GPT-3 to generate a whole load of conversational examples like questions and answers. And then this is the crucial bit. They fine-tuned Llama 1 on those GPT-3 outputs.
So teaching the smaller model using the bigger one's example.
Exactly. And they created Alpaca for less than $600. Total cost.
Under $600.
My God,
That's astonishing compared to the millions people thought you needed. But Alpaca wasn't just about costs, was it? It felt like something bigger shifted then.
Oh, completely. It was this huge unlock because suddenly it showed you could democratize model creation.
Yeah.
The barrier to entry just plummeted.
Right.
It proved you could transfer not just the knowledge, but also the style of a huge, expensive model like GPT-3 onto a much smaller one.
Oh.
Which meant, you didn't need a $10 million training budget anymore to make your own unique model. If you had unique data, specialized information, you could potentially package that up as a service using a fine-tuned language model.
So the prediction then was...
The immediate thought was, okay, we're going to see tens of thousands, maybe hundreds of thousands of these models popping up, all this specialized knowledge finally being distilled into software you could actually use.
But there was still a catch, right? Even with Alpaca showing the way these open weights models, they were accessible in theory, but still kind of closed in practice. What was the issue?
They were still black boxes, basically. You download the model, these billions of numbers, the raw weights, but you wouldn't really know what's it good at, what are its strengths, how do I even use it properly? And the proof was in the pudding.
Yeah.
Despite how important Alpaca was, very few people actually used Alpaca for real applications. It just highlighted this massive gap. We needed better ways to discover these models, understand them, and actually use them easily.
Okay, so models are getting cheaper to make, thanks to things like Alpaca, but they're hard to find and hard to use. Sounds like a perfect opportunity for something new. Is this where OpenRouter comes in?
Exactly. The stage was set. But before OpenRouter itself, there's this interesting experiment in April called Window AI.
AI.
Yeah, it was an open source Chrome extension. And what it did was let you, the user, choose which AI model you wanted to use for any web app you were on.
Oh, interesting. So you could bring your own AI to any website.
Pretty much.
Yeah.
Without the website developer even needing to build in support for that specific model. It was a really neat idea. And that project, Window AI, directly paved the way for OpenRouter.
So how did OpenRouter build on that Window AI idea?
Well, OpenRouter launched literally the next month, May 2023.
Yeah.
It was co-founded by Alex Atala, and Lewis was the founder of Plasmo, which was the framework Window AI was built on.
Okay.
And the initial vision, pretty straightforward, actually. Just create a place to collect all the models in one spot and really try to help people understand them and get access.
So it started as a collection. How's it evolved since then? What does OpenRouter do now that makes it so important in this AI world?
Oh, it's grown massively. Today, it gives developers, really good prices, great uptime, no subscription fees. It genuinely offers the most choice when they're picking the intelligence for their software.
And the growth reflects that.
Absolutely. It's been growing 10 to 100% month over month for the last 2 years. Phenomenal growth.
Wow.
Functionally, yeah, it's an API. It gives you seamless access to all language models. But it's more than that. It's become the go-to place for data about who's using which model. And the really powerful thing is what we call near zero switching costs.
Near zero switching costs, meaning
Developers can swap out one model for another almost instantly without having to rebuild everything. It's incredibly flexible. We're talking over 400 models now from more than 60 active providers. Supports different payment methods, even crypto.
So it handles all the messy stuff behind the scenes.
Totally. Things like normalizing tool calls.
Yeah.
That's how models interact with external services or APIs or caching results to speed things up. OpenRouter handles that complexity, making sure you get the best prices and features without needing to become an expert on every single provider's quirks.
You said it started as just a collection, but then it became a marketplace. How did that happen? You mentioned this out-of-control, heterogeneous monster. What was that?
Yeah, so initially, right, when the first open source models like Llama started appearing, we'd just list maybe 1 or 2 providers for each model on OpenRouter, a primary one, maybe a fallback. We didn't even name them.
Okay.
But it quickly became obvious that lots of companies wanted to host these models, and they were doing it at wildly different price points, different performance levels.
Right.
And crucially, the whole messy mix of features. Some providers supported advanced controls, like MIMP, for tuning randomness. Others had tool calling. Others offered structured outputs for getting back predictable data. But almost none supported all of them consistently.
Ah, I see. So every provider was slightly different.
Exactly. This huge variation across providers, features, price, performance.
Yeah.
That's what created this Yeah, this out-of-control, heterogeneous monster of an ecosystem was getting really complex really fast.
So how did OpenRouter step in to tame the monster, as you put it? What was the shift to becoming a marketplace?
Well, the core idea was, okay, let's just aggregate all the providers for a given model in one place. Let's show their different prices, list their features clearly. That's how it turned into a true marketplace.
Makes sense.
So now, for example, if you look up, say, the Llama 3 70B Instruct model, there are 23 different providers currently offering it on OpenRouter.
20.
Yeah. And this aggregation does something else really important. It boosts uptime for both open and closed source models because we're pooling all the demand and all the supply in one place.
Okay.
And maybe most importantly for developers, we now show actual real-world data, graphs on latency, on throughput, so you can make a really informed choice based on how these models actually perform, not just promises.
This seems to lead us right back to that fundamental question we started with, the winner-take-all idea for AI itself. Given OpenRouter's unique view across all these models and providers, what does your data suggest? Is one winner likely?
Based on everything we see, tracking usage by model author, tracking tokens processed, the most likely bet is that that is not the case. Definitely not.
Not winner-take-all.
No. We're seeing clear, undeniable diversification. Look at Google Gemini, for instance. It started around, what, 2–3% of usage on our platform back in June last year. Now it's steadily grown to 34–35% in just 12 months.
Huge growth.
Huge. Anthropic's models, like Claude, are also incredibly popular. And even OpenAI, while their usage might look a bit lower on OpenRouter, specifically because of how some devs use ASO, their overall usage in the wider market has also grown significantly. It's not a zero-sum game.
That's a really strong counterpoint to that early narrative. Is there any argument left for a single winner, or does the data just shut that down now?
Look, there will always be very large, very capable general-purpose models, sure. But the economics and just plain user behavior, it all points towards diversification. People need models for specialized tasks. They need different moderation approaches, different performance profiles.
Right.
It's just too hard for one single model, one single company to be absolutely the best at everything for everyone. That all things to all people idea.
Yeah.
It just doesn't seem feasible in this space as it's evolving. The future, it's definitely multi-model.
So your customers are actually finding, okay, for this task, Model A is better, but for that task, I need Model B.
Absolutely. We see it all the time. Customers use different models for different jobs, and they get huge gains by doing that. Maybe one for creative writing, another for code, another for analyzing data.
Makes sense.
And inference itself is becoming a commodity really fast. Like if you're getting Claude through AWS Bedrock, it needs to look and feel exactly the same as getting Claude through Google Cloud Vertex AI.
The plumbing needs to be invisible.
Exactly. And because inference is going to be a dominant operating expense for so many companies using AI, being smart about model selection, about routing requests efficiently, that's going to be absolutely crucial.
And people stick with this multi-model approach once they start?
Yeah, the data shows the number of active models people use on OpenRouter has steadily grown. And once they start using multiple models, that usage tends to be pretty sticky. They see the benefits.
Okay, building this whole thing, managing this incredibly diverse ecosystem, it must involve some serious technical heavy lifting. You mentioned achieving really low latency earlier. That sounds tough with so many moving parts. Can you give us a peek behind the curtain? What made that so hard?
Oh yeah, latency is a constant battle. Imagine, like you said, hundreds of different models, dozens of providers, all with slightly different ways of responding, different network paths.
Right.
Trying to get consistently fast responses across all of that, it's a challenge. The biggest hurdle for us was designing our caching system. It had to be smart enough to store and retrieve bits of information really quickly in a way that worked efficiently, no matter which model or provider was actually handling the request underneath.
So not just a simple cache.
No, definitely not. It wasn't just about, throwing more servers at it. We had to really understand the patterns of how data flows, especially with streaming responses where the model sends back words or tokens as it generates them. We ended up doing a lot of custom work, really digging into how data chunks are managed in those streams. And that led to some maybe counterintuitive approaches to finally nail that extremely low latency. We're talking around 30 milliseconds overhead, which, yeah, we think is best in the industry.
30 milliseconds, that's impressive. Okay, besides caching and latency, what other gnarly problems did you have to wrestle with to make this whole ecosystem feel seamless for developers?
Well, one big architectural thing was wanting to add new capabilities to inference, but doing it in a way that worked for all the models we route to.
New capabilities, like what?
Things like adding real-time web searching
Hmm.
or being able to robustly parse information from PDFs, features that the underlying models themselves might not natively support.
Ah, okay. So augmenting the model.
Exactly. And the initial thought might be, okay, do some processing before you send the request to the model. But we realized we also needed to transform the output as it came back, again, universally.
How do you even do that? Add web search to hundreds of different models without building custom code for every single one.
We built something we call AI native middleware. Think
Mm.
of it like middleware in web development. Like in Next.js, you might have middleware for authentication or caching that runs on every request.
Okay, yeah.
Our middleware is optimized specifically for AI inference streams. So, for example, our web search plugin, it literally augments every single language model on the platform with web search. It fetches results, processes them, and injects relevant snippets as annotations right into the streaming response, going back to the user, all happening in real time.
Wow, that's clever. Any other big headaches?
Oh, stream cancellation. That was a fun one.
Stream cancel.
Yeah, when a user decides to stop the AI response midstream, every provider handles billing for that differently. Some might bill you for the whole expected response anyway. Others bill for the next, say, 20 tokens even after you cancel. It's wildly inconsistent.
Oof. Yeah, that sounds messy for developers.
Totally. So a big part of our job is figuring out all those weird edge cases for every provider and standardizing it. We try to present a simple, consistent behavior to the developer so they don't have to become experts on the cancellation policies of 60 different companies. It's that overall challenge of standardizing this incredibly diverse landscape.
Right. So looking ahead then, you've tamed the monster, standardized a lot.
Mm.
Where does OpenRouter go next? And what does that signal about where AI itself is heading?
Well, definitely more modalities
Yeah.
beyond just text.
Images, audio.
Images are a big one coming up. We're starting to see LLMs that can generate images in a much more integrated way. Some people call them transfusion models.
And fusion model.
Yeah, think of it like blending the deep world knowledge of a large language model
Yeah.
with the image generation power of something like Stable Diffusion.
Okay. What does that enable?
It means images generated with way more world knowledge
Hmm.
baked in. And crucially, the ability to actually talk to the image, have a conversation about it, we think that's going to be huge. Imagine generating an entire complex menu for a delivery app with images and descriptions just by describing what you want. Using one of these transfusion models, it's going to be really exciting.
That sounds powerful. What else is on the roadmap?
More powerful routing is a big one. Moving beyond just basic stuff like sending requests to the nearest server towards real enterprise-level optimization.
Hmm.
Thinking about routing to literally the right GPU in the right place
Hmm.
based on cost, latency, current load, really sophisticated stuff. Also, better observability for prompts, helping devs understand exactly how their prompts are performing. Enhanced discovery, too. We want really fine-grained categorization for models. So you could find, say, the absolute best models for understanding Japanese and creating Python code, that specific niche.
Super specific filtering.
Exactly. And of course, always working on getting even better prices for developers.
And underlying all of that, what's the core philosophy driving OpenRouter forward?
It really comes down to enabling collaboration.
Right.
We want to help build an AI ecosystem that's durable, one that isn't locked down. And fundamentally, that means ensuring low vendor lock-in. It's all about empowering developers with choice and fostering real innovation across the entire field.
Well, this has been a truly fascinating journey today. We went from, that simple sounding question about market dominance in AI right through to the creation of this dynamic marketplace OpenRouter that's actively shaping a multi-model future. And we saw how innovation isn't always just about building the next biggest model, right? It's also crucially about building the infrastructure, the plumbing, like you said, that makes all these models accessible, affordable, and actually useful in the real world.
Yeah, absolutely. And the story of OpenRouter, I think it really highlights this fundamental shift happening, the power of AI. It's moving beyond just a few huge centralized companies and more into the hands of many. It's fostering this ecosystem where diversity, specialization, choice, these are becoming paramount.
So thinking about that diverse multi-model future, what stands out to you as AI gets woven more deeply into everything we do and our options for different kinds of intelligence just keep expanding? What new possibilities, what new applications might this multi-model world unlock for us? Things that maybe a winner-take-all world might have actually suppressed.